Assalamualaikum. My name is Bisma Nisar. My roll number is 21T39. In task 1, first of all, we define a function v is my def, then define length, then define zeros, then starting for loops k, then starting another for loop, then we define a function that is a Boolean function in MATLAB. That is yk plus 1 is equal to yk plus 1 plus xn plus 1 exponentials minus 11 multiply 2 multiply pi multiply k multiply n divided by n. Then ending for loops. Now we define inverse DFT same like previous ones. We define length, then define zeros, then starting the functions. Then starting functions for loops is then starting another for loop that is k is equal to 0 and minus 1. Then define Boolean function, then end the function. The only difference between DFT and inverse DFT is minus sign phase. There is another x and when n plus 1 is equal to x n plus 1, then ending for that loops. Then we define a function of IDFT functions. IDFT functions, we define output. Before that we take second action defining of, then display the DFT coefficients, then calculate inverse DFT, then display the reconstructed sequence. Then taking third x is equal to 1 2 3 2 3 4 1 2, same like previous one, then display DFT coefficients. DFT stand for discrete Fourier transform. Display by DFT, then display DFT coefficient, then display the inverse DFT, then display the reconstructed sequence. As a result we get 4 outputs, 4 inputs. इन टास्क 1 में हमारे पास DFT की जो आउटपुट कोफिशिएंट्स हैं वो हमें ये दिए हुए हैं, IDF क्या कोफिशिएंट्स हमें ये दिए हुए हैं. In task 2 we have a range of x from x1 to x11 and we define all in the sequence. Then we figures for figures, then we plot. That's why we use stem command, then give title. As a result we get output. In task 3 we use some built-in function of MATLAB that is f of t, that is fast Fourier transform. That is we define x is equal to 1 2 3 4, then we build in commands of MATLABs fast Fourier transform. As a result we get output. Secondly, actually we plot real terms. For that we use real x-axis. As a result x real, then we find x imaginary. For that we use x imaginary and we get imaginary terms. Finally we get absolute terms. For x that we use built-in function that is ABS. As a result we get absolute terms. In task 4 is same title task 2 with some iterations. First we define x is equal to from x1 to x11, then we separately define from x1 to x11 as an FFT, that is the built-in function of MATLAB. So define these from x1 to x11 as in term of FFT, then we separately define each of them from x1 to x11 in magnitude, phase and power. So we define it from x1 to x11, and after defining plots all these terms, after defining plots all these terms, for this we use subplots 3 1 1, then use stem command, then give title, then labeling of x-axis and y-axis, then again use subplots that is 3 1 2, then give title, x label and y label, then again use subplots c1 3, that title and x label and y label. As a result we get output of magnitude spectrum, phase spectrum and power spectrum. That's all about slash 5. Magnitude spectrum of multiply 5, phase spectrum multiply 5 or power spectrum multiply 5. Thank you so much. Allah Hafiz.